Part 2 of the discriminant. Okay, so yesterday we established that the content under the square root of the quadratic formula will be dependent on the number of roots that you have. Okay, so b squared take away 4ac. Of course, we don't need the actual square root, we just need to consider whether the expression for b squared take away 4ac for your quadratic formula is positive, 0 or negative. Okay, and then obviously there'll be other conditions when it's positive as well, in terms of having integers or rational or irrational roots. Okay, but in general, that's what we're looking at. Okay, so it's called the discriminant. So we had a look at the conditions for those: greater than 0, less than 0, or equal to 0. And now we're up to the examples. So, example A. Right, determine the number and the types of roots. Okay, so y equals 5x squared, take away 7x, plus 3. Right, so previously we've been asked to graph it, so we use our factorising skill for factorising quadratic to find the roots. If we can't do that, then we try the quadratic formula, okay, to identify the roots, the intercept where they cross the x-axis. Okay, these questions here are just asking you to determine the number of the root and their types. Okay, so all we have to do is substitute into the discriminant. Okay, so the discriminant is b squared take away 4ac. So remembering our quadratic, ax squared plus bx plus c. We simply substitute those variables into that. Okay, so negative 7 or squared minus 4 times 5 times 3. 49, 20 times 3, and it'll be negative 60. Okay, so I don't have to go ahead and work out the actual number. Alright, so all I need to do is say from this point, I know that's going to be less than 0 because I am subtracting a larger number from a smaller number. So you're showing that sort of evidence, or you show the actual calculation negative 11. Okay, so if the discriminant is less than 0, what can you say about the roots? No real roots.
Or are there?
Dun dun dun. Okay, so therefore no real. Okay, Miguel and Robin had a lot of fun this morning with 2 complex roots in that sort of setting. Don't show your hairs out. Okay, oh, and sorry, so we had to determine the number of roots and the types of roots. Okay, so how many roots are there? So no real root, and root's not real. Just to cover all bases. That would probably be enough for me. I can't say the same for your HC marker. Alright. Next one. B. Y equals 6x squared. Take away 7x. Take away 5.
Wait, no real roots, the roots are not real.
Exactly. So, how many roots? Types of roots.
That's some Jaden Smith stuff.
So just covering all bases and making sure you're getting your marks there. Okay? For me, that first sentence would have been fine because that says both, but you don't want to have a picky marker for your HSC that's going to grant a bit of that. Alright, so again, we need to determine the number of roots and the types of roots. Okay? So we do that by determining the value of the discriminant. Okay? I don't need to know what the roots are, just need to know the number and types. Okay? So, okay, so get to the point where it's obviously that it's greater than 0, or it's obviously less than 0, or it's obviously is 0. Okay, so from this point we can say what? Okay, so therefore there are 2 real roots, distinct real roots in there as well, and the types of roots.
What do you mean by types?
Okay, so the discriminant is 49 plus 120, which is 169. Okay. Now, remember that the discriminant is underneath the surd. So if I take the square root of 169, I have what?
13, we did this morning. It's 13. Yeah.
So the square root of the discriminant is 13. Okay, so remembering this is in your form x is minus b plus or minus 13 on 2a. Okay, so that's where that pops in there. Alright, so because you've got the 13, you're going to be adding or subtracting another integer, and you're going to be dividing by another integer. Okay, so that means, therefore, the roots are rational. Okay, because 169 is a perfect square. If it wasn't a perfect square, let's say it was 170, then the roots will be irrational, because if I take the square root of a number that is not a square number, I'm going to have a long, complicated, irrational number. Okay, so we need to determine the number of roots, and they're both rational because of the further work I've done with the discriminant. So how much of the maths this morning going through your mind right now?
It's just disappeared.
Alright, next couple of examples. Find the values for m, for which mx squared, take away 2x plus m, equals 0 has real root and equal roots. Alright, so, see? So, mx squared, take away 2x plus m, equals 0 has real roots. So how am I going to work this out?
B squared take away 14c is greater than 0.
Good. The discriminant is greater than 0. When we have the discriminant greater than 0, we will have 2 real roots. Okay?
Could it be greater than or equal to 0?
Had real roots. Find the values of m. Real roots. That's a very technical one, isn't it? Because you can have one root that's still a real root, but you've got the plural for real roots. So the discriminant has to be greater than 0 because you want the plural. Okay? Would be my understanding, but I'll get that confirmed. Alright, so discriminant equals, b squared minus 4ac. So negative 2 all squared minus 4 times m. Okay, and we need that part greater than 0. Alright? So, 4 minus 4m squared has to be greater than 0. Tidying that up. Okay, and solve for m. Alright, so negative 4m squared is greater than negative 4. M squared is less than 1. Okay, so when we're dividing or multiplying by a negative number, the sign of the inequality is reversed. Okay, m is critical point. M is equal to plus or minus 1. Okay, so this is the parabola 4 minus 4h squared. Okay, in other words, it is negative 4h squared plus 4. Right, is it concave up or down?
Up. No, down.
Down, it opens downwards. Okay, opens in downwards direction.
But if m can equal plus or
I'll
minus-
forgive that today because of what you've gone through this morning.
But if m equals plus or minus, then that...
Okay, if I replace my m's with x's, alright, I've got x equals plus or minus 1, which is the x-intercept, isn't it? For the critical point. Okay? For that particular parabola there. Alright, not the whole parabola, but for that particular one there. Okay, so we do a quick sketch. Okay, quick sketch. So we know that it's concave down. Okay.
I'm really worried that I'll be doing extension 1 or something and I'll start doing complex numbers. I'll keep going.
There won't be much. There won't be much possibility in extension 1 we can use complex numbers. I'll tell you now. Okay, so concave down and plus or minus 1. Okay, so where is the graph of 4 take away 4m squared greater than 0?
Negative 1 and 1.
So greater than 0 means you've got positive y value, remember, above your x-axis. Going back to this inequality here. Okay, that's what you're matching. So, negative 1 is less than m, which is less than 1. Okay, now note this parabola is not this parabola here. Okay, any value between negative 1 and 1, not including, that I'll substitute for here, for the value for m, okay, I am going to have two real roots. Okay, and technically, I have to get that verified in terms of whether we can just have the one root when it's negative 1 or 1. However, I'm pretty sure that that's the question anyway. Equal roots. So, m x squared take away 2x plus m is 0 has equal root. Okay, and we've already done the work, haven't we? Okay, because the same thing I'll be doing is setting that inequality. Okay, so what's the condition for the discriminant for it to have equal roots? Equal 0. Okay, so in other words, the discriminant has to equal 0 for equal roots. Now, it's the same working here, except for my inequality sign is going to become an equal sign. Okay, so instead of the critical point, they are the solution for my answer. So from part C, m is going to be plus or minus 1. Okay? So if I substitute that back into that original parabola, so i.e. x squared minus 2x plus 1 when m is positive 1. Okay, and we can factorise that to the perfect square. Okay, so in other words, x take away 1, or squared is 0. We've got one root there. Okay, and it is also equal to negative x squared, take away 2x, take away 1 when m equals negative 1. Alright, so if I factorise the negatives out, and then I can show that I only had one root. So take away x squared plus 2x plus 1, and I've got it again. So two numbers multiplied to give 1, same two numbers add to give 2. So we've got negative x plus 1 all squared, and that only has one root. Alright, so that's what you're doing. Alright, so even though you're setting up a different quadratic, right, you're using the answer for that quadratic back into the original question. Alright, so this is what I need. Okay, the value for m gives it equal roots. Question. 10.3. Okay, these are all still in your prelim text. You won't need your HSC text till the start of week 3.
And what topic will